So super edgy is an acronym. Stands for Swing Up, S-U-P, of Quantum Emitter, ER, population. It's a super project we're doing, and I want to explain to you what this is about. So let me first set the background. The idea is we want to do quantum communication, but instead of communicating like via the telephone wire or by the optical fiber, we want to use quantum light now. So quantum light is a single photon that basically is the smallest portion of light. Now, all these properties which I talked about, which are now relevant, they come into that. We're going to want to harness them. We want to make use of them. And why do we want to use that? If we do that, we have a secure communication. So if we're talking, and it would be a secure line, and someone would tap in and listen to our very private conversation, we would not see that person, but we would know we would have been listened to. And remember all these movies, which are like, you've seen Enigma, which was like all about secure communication. We now understand how important secure communication is. And the quantum communication is one idea how to make communication super secure, like from the fundamental ideas of physics secure. It is a different way of security. So cryptography, I give you a key. Someone could still and decrypt our messages. This is what happened a lot of time. Now, the secure way how to distribute it, on which way it goes, you can copy a regular key. That's easy. If it's a line of numbers, you can copy that just with your notebook. You cannot do that in quantum mechanics.
Why not?
Oh, there's the theorem which is actually called no cloning theorem. We rely on that. It's more complicated than that, but the idea is in quantum mechanics, there's not just zeros and ones as from a classical computer, but you can have everything in between. That is called a phase or a coherent superposition thing. But the still thing is you can still just measure 0 or 1. But say it was in the middle. It was half 0, half 1. So it's 50-50. You can get one or the other. Yeah, that's one thing we named. So you can make a couple of repetitive measurements and thereby get the statistics, and you will know that instead just giving 50-50 regularly, you took a quantum 50-50. And this is where it all relies upon. And then this was the first proposal. It was given like 40 years ago. And now we're trying to implement that, and they're more complicated of these proposals. But you cannot copy the quantum state because while measuring it, you need to destroy it. And then reconstructing it is tough. You have the key, I have the key, but nobody has copied it.
What you're working on is more about the securing the communication. Oh, this is so cool. That's why it is super quantum.
Oh, that's not why it's super quantum. We need these single photons, these little bits of light to go there. That's a requirement to make all this happen, which I just told you about.
Correct.
And now to get that, what we can take is what is called a quantum emitter. That can be an atom, and you can excite it. But re-excitation, it will lose its excitation, it will emit the single photon. So now the question is how to excite it. So imagine that you want to go up in the swimming pool, you want to go up the ladder and jump in the pool. That's a similar process because you excite yourself and the pool splash is basically the single photon. You would take a ladder to go up, yes?
Yes.
And the ladder should be probably the same size as the tower, yes?
Yes.
That's how we do. That's what people have done before. You can take a ladder which is a little bit higher. That would be okay, yes? And you can, that's okay. What we do now is we take 2 ladders, but both are too short. Just a little bit too short. Just like you try to stretch, it doesn't work. So basically, we attach the ladders in a smart way to each other, and you have to jump from one to the other to get up. So super edgy is an acronym. Stands for Swing Up, S-U-P, of Quantum Emitter, ER, population.
The swing up, quantum emitter.
Yes.
And the R of the...
Oh, this is so cool.
Oh, okay. Okay. This is cool. Okay, now I will understand all the jokes moving forward. Thank you.
So we just published that 2 years ago. It's 2.5 now. And it was very unsearched for. That was very surprising to everybody, but also very much needed to everybody. So people really went to the lab immediately after we brought it out and tried to measure it. And it worked. So this is the best thing if you're a physicist. You propose something which you think is like totally just your mind, and then it works and you're like, yeah.
We hope you enjoyed this snippet. Check out the full episode by following the link in the show notes.